Okay, guys, let's look at section 9.8, the last section here of chapter 9 of the trigonometry here, using sum and difference formulas. And you're going to want to refer to the core concept chart on page 520, which has all of your sum or difference formulas. Okay, so let's just start with an example here. Say I wanted to evaluate sine of 15 degrees. Example 1. Well, the sine of 15 degrees we can use, well, a difference formula in this case, okay? Because I can easily get to 15 degrees if I do sine of 60 degrees minus 45 degrees. Well, now I have the form there of sine of A minus B, which is sine A cosine B. Let me just write the general form. Minus cosine A sine B. And these are again my A and my B. Okay, so that's going to be sine of 60 cosine 45 minus cosine 60 sine 45. Okay, and then if I'm in the 60s, I know a sine of 60, that's going to be the y value. That's long side, so that's root 3 over 2. Going back to my unit circle. Cosine 45 is root 2 over 2. Then a cosine of 60 degrees would be 1/2. And the sine of 45 is root 2 over 2. Okay, which is essentially now here root 6 over 4 minus root 2 over 4, which we can then combine to root 6 minus root 2 over 4 since they share a common denominator there. Okay. Well, so what would I do? I said, well, 15 degrees is the difference of two of my special angles I know, a 60, a 45, or a 30. So we're usually using the 90s, the 60s, the 30s, or the 45s to get to one of our angles that maybe isn't one of our special angles by using these sum or difference formula. And here's the actual general formula that I then used. And remember, this is my A here, and this is my B here. Okay, let's look at another one. Okay, let's look at another example here, tangent of 7 pi 12ths, which is really the same as tangent of pi thirds plus pi fourths. Because remember, if I say multiply that by 4 over 4 and that one by 3 over 3, that would be 4 pi 12ths plus 3 pi 12ths, 7 pi 12ths when I add them together. Okay, so sometimes it's a little, you got to kind of look for them, and it's a little more challenging if in radians if you're not used to working with radians. But the same process applies. Then let's write the general formula here. And remember, this is going to be my A, and that's going to be my B, and we've got A plus B. Tangent of A plus B is here tan A plus tan B over 1 minus tan A tan B. Okay, and now it's just a matter of plug and play. Tan pi thirds plus tan pi fourths over 1 minus tan pi thirds tan pi fourths. Okay, and if we know our unit circle and we know these locations, we can hopefully construct these not too bad. And remember, a pi thirds is a 60. And if you need to, you can always draw, say, a 60. And I say, oh, that's long side root 3 over 2, short side a half. Tangent would be opposite here, root 3 over 2 over a half, invert and multiply, 2 over 1, 2's cancel, root 3. Okay, so that's going to be root 3. And then I remember with pi fourths, well, that each of my legs is the same length for the 1, 1, root 2 triangle. So that would just be 1 over 1, which is 1 over 1 minus root 3 multiplied by 1. Okay. Okay, so what did I do? First I had to figure out what got me to 7 pi 12ths, and it's sometimes not always easy to tell, oh, it was pi thirds plus pi fourths, but notice I showed you how they got to that. You could say 4 pi 12ths plus 3 pi 12ths equals 7 pi 12ths, and then you could reduce them to these two. Okay? And then I wrote my general formula, and then it's just a matter of plugging in. And remember, here's my A value, and there's my B value. So tangent of A plus tangent of B over 1 minus tan A tan B. And here I just drew a quick unit circle if I was, say, not sure what this was, remember, a 60 here. 60 degrees, and I'd say, oh, long side, short side, and construct it, okay? Okay, so then I'm left with root 3 plus 1 over 1 minus root 3. Okay, well, whenever I have a radical in the denominator, I have to rationalize. So let me undo here. Let me erase this. Okay, and so that's root 3 plus 1 over 1 minus root 3, essentially, that becomes 1 minus root 3. Well, remember, if I'm going to say, deal with this, I have to multiply by its conjugate, top and bottom, 1 plus root 3, which is the conjugate of this one down here, right? Top and bottom. 1 plus root 3, top and bottom, okay? Okay, and then when I FOIL, that's a plus b times a minus b, which is a squared minus b squared in the denominator. 1 minus root 3 squared is 3. Over, when I FOIL these out, that's really root 3 plus 1, a plus b times a plus b squared. A squared plus 2ab plus b squared, which would be 1 squared plus 2 times root 3 squared, which would be 3. No, I'm sorry. Have that back. A squared plus 2, and let me just rewrite this, 1 plus root 3. So you see what I'm doing here? That's just a plus b times a plus b, which is a squared plus 2ab, which would be root 3, 2 root 3 times 1, plus root 3 squared, which is 3. Okay, and let's see if we can do any further simplification here. And let me go ahead and erase here. So what did we do? We multiplied by its conjugate here, top and bottom, the conjugate of what was in my denominator, which is this 1 minus root 3. So I multiplied by 1 plus root 3, top and bottom, just like multiplying by 1, remember? That's just changing the form, but not the value. Okay, let me erase. And then when we did 1 plus root 3 times 1 plus root 3 on top, we got that. And 1 plus 3 times 1 minus root 3 on bottom, we got that. All right, and we're getting there. Let's finish simplifying now. So 1 squared is 1 plus 3 is 4 plus 2 root 3 over 1 minus 3 is negative 2. Now, that negative 2 can go to both, and remember, it only cancels with what's outside of the radical if that's also outside, right? So that would change both the signs into negative 2 cancels here with the 4 to make it negative 2, and then both 2's cancel, but you're left with the negative there, negative root 3. Negative 2 minus root 3. Okay, so make sure when we're canceling this, it cancels to both quantities, and it has to only cancel the things outside. And if there's nothing that's outside that can cancel to both, then we're going to leave it as is. But this goes into both 4 and 2. And then notice I canceled and reduced it, and the negative went with it when I did that too. Okay, thank you. Okay guys, let's look at one more example here, number 6 from your homework, sine a negative 165 degrees here. So sometimes it's a little hard to tell which 2 angles I want to use to maybe get me there. Something like this I might really break up into negative 120 minus 45 degrees. Okay, and so now we've got sine of A minus B, and if I look at my chart, sine of A minus B is going to be sine A cosine B minus cosine A sine B. And remember, that's A minus B. So really B is 45. And A here is negative 120. Okay? So let's write it. Sine of negative 120 cosine of regular 45. Notice the negatives built into this A minus B formula. Okay? Minus the cosine of negative 120 sine of 45 degrees. Okay, and if we're having trouble thinking, well, what's a negative 120, don't be afraid to say draw it and move it, right? Initial side here on the positive x-axis. And let's go 90 plus how much more to get to 120? Well, another 30. So I essentially have this reference angle of a 60 in the third quadrant. Well, a 60 in the third quadrant here, that's going to be root 3 over 2, but remember it's negative here. And that's going to be negative 1/2, short side, long side. So remember when you're constructing these angles, you want to do the reference angle to the shortest distance to the x-axis, and then think about short side, long side, and then hopefully we can construct from there. Okay, so a sine of negative 120 degrees here, this is our negative 120, is really this right here, which is a 60 in the third quadrant. So sine corresponds to y, so that's negative root 3 over 2. And cosine of 45, that's an easy one. That's root 2 over 2 in the first quadrant. Remember, cosine and sine are the same there for a 45. Minus cosine of negative 120, which is essentially the cosine of the 60 here, which is negative 1/2. And sine of 45, root 2 over 2. Okay, let's multiply. Negative root 6 over 4 plus, because 2 negatives multiply there, root 2 over 4. Okay, so then we can write them together, and usually we want to put the positive component first. So that'd be root 2 minus root 6 over the shared common denominator of 4. Root 2 minus root 6 over 4. Okay? So remember, as you're constructing these, you might have to use some like 120s in there, but remember, a negative 120 is really just a 60 in the third quadrant. Draw that reference angle up or down to the x-axis, construct your two sides using what you know of the unit circle, and then go about finding what sine and cosine are. Remember, sine corresponds to y on the unit circle, cosine corresponds to x, and then you can hopefully construct these with a little more ease. Okay, so let's try the first 10 here on page 523, and then we'll go from there. All right.